All right, let's go. A piece of cardboard measures 18 by 10. You are going to fold it by cutting off squares into an open top box. We've done a problem like this before. I told you the reason why we did it so that you would see it again and understand it. Remember, I even had a visual aid where I cut off the corners of the sheet of paper and I folded it up. You guys remember that? Yeah, it's one of my best teaching moments. Well, maybe you shouldn't sleep during class. So, this is a good point. All right, so we've got 18 by 10. And I am going to cut off x by x. Gina remembers it. I did. I think I cut it during first hour. What up, G? Yo, shout out on YouTube. Rhiannon, take it away. Shout out to Miss Gross.
Hi, Mr. Grossklaus. I just want you to let you know that right now I am really confused in math class, yet I love it. So here we go. Oh, follow me on Twitter, Rhiannon_Park.
He doesn't realize how normal that is, right? It's like, okay, all right, here we go. So, you tell me what's driving the problem. What's driving the problem? What is the phrase that's driving this problem that I need to pay attention to? Largest volume. So what I want to do is I want to maximize the volume. Can somebody tell me what formula should I be writing down right now? Very good. Length is volume is length times width times height. Now, in this problem, I know the original piece of cardboard is 18 by 10. But if I want to write this in terms of length and width and height, tell me, is the length more than 18, less than 18, or 18? Less than 18. Why? How much are you cutting off? X and X. So the length is 18 minus 2x. Good. The width, 10 minus 2x. And the height, x. Good. See, we've been down this road before, haven't we? So the volume in terms of x is our variable, is going to be x times 18 minus 2x times 10 minus 2x. What degree equation am I going to come up with? Yep, cubic. So third degree. So let's multiply this out, come up with a polynomial, and we will have some fun. All right, I got 18 times 10. Distribute the x. I got 180x. Okay, you want to go that route? Okay. Let's pause there. So Michael went straight to the negative 2x and negative 2x for a positive 4x squared. But let's do the middles, okay? So I got a negative 20 and then a negative. So I got a negative 56 and then distribute the x, you'll get an x squared. So then we'll take his positive 4x squared and distribute the x to get a 4x to the, and you guys told me I'd come up with a cubic, so there I have it. So is this cubic right side up or upside down? Right side up. Am I looking for the maximum or the minimum? Maximum. So, can I do negative b divided by 2a? Why can't I do it? Because it's a cubic, not a... So you got two options, folks. You either do calculus or your graphic calculator, but none of us know calculus. So, I do, but... Yep. Okay, so I type it in, and so we all see the same window. I'm going to do Zoom 6 for a Zoom standard, and not very happy, right? So this is probably the most confusing part of the day for you. So hone in and try to figure this out. Right now, I do not see the appropriate graph because what do I need to change? Okay, so I got my window. I got these x values. What does x represent in the problem? The height, which is also how much I'm cutting off, right? So tell me a number. What's the most that I could cut off? I mean, 18, but actually, if you reduce it to, say, 9, right? Because 9 by 9, then you'd cut everything off. And actually, if you look at the shorter side, 5 by 5, right? So if just, in case I miss some of that, if I make it all the way up to 20, well, I for sure see everything in the X window that I want. For sure, no doubts. Okay, I'm going to make a scale every 10. Now, the Y values is really where people start to get confused. What does Y represent in this problem? The volume. See, this is my Y value, the volume. So let's just take a sample number and see what the volume would be. How much would you like to cut off? 1? Okay. So if we cut off 1, that would be the height. What would then be the length? 16. What would then be the width? 8. And 16 times 8, so 128. So it looks like the volume is in the hundreds. It doesn't look like it's going to be in the thousands or the millions. It's in the hundreds. So I'm going to make my Y min say negative 400 and my Y max positive 400. At least I got a general idea of what that's going to be. If it's not right, I can always zoom out. Let's check the graph. We see a nice maximum. How do we calculate it? With the 4? Okay. Let's interpret the answer. What do I want for, what is the problem asking for? Is it asking for the dimensions or the volume? The volume. Do one of the numbers up there represent the volume? What is it? It's Y. So it's 168.13 inches cubed. Yes. Yes, that is your answer. Oh, it's minus 56. You get 56x squared. Okay. Next problem. Find the dimensions that give the largest area. Everybody say bye, Dr. Grossklaus.
The funny part is I was trying to do an observation.
Okay, here we go. You don't know how many times that conversation's come up. All right. All right, so we have a parabola. How did I know the parabola looked like that? Negative 3x squared goes through positive 12. Anybody want to be really sharp and tell me what the x-intercepts are? Very good. You factor it, you get negative 2 and positive 2. And the deal is that I'm going to have a rectangle that sits on the inside whose corners are on the parabola. We're not ready to do open heart surgery, Gina. We have to deal with parabolas inside, or boxes inside parabolas. So I've got xy, got negative xy. Somebody tell me what this coordinate down here is. Negative x, 0. And this one would be positive x, 0. Okay, cool. I got a drawing. And in your book, the drawing will be given to you. But what is driving this problem? So what formula should I write down? Yep. And I'm going to use, in this situation, base times height. And I'm going to use that because it talks about the base of the rectangle. So I need an expression for the base. No bad guesses. Maddie, come on. Own it. Whatever. Yo, Nemec. You have really good idea, okay? But it's standing there right in front of us, folks. Has something to do with X, but it's not X. It's 2X. Why, Jake from State Farm? Yep, you got X this way and X this way. That's a total of 2X. What's the height? Y. So I get area is equal to 2xy. Oh no, I still have two variables. If only I could get rid of the y. It's right there. It's right in front of you. If it was a snake, it would bite you. Y is 12 minus 3x squared. Way to go. Well, y represents the height, and it says that in order to determine what y is, that we would take the x value, square it, multiply by -3, and add 12. What's that? Because the distance from here to here is the same as whatever the y coordinate is. Sweet. Area in terms of x is 24x minus 6x cubed. How is this different than the last problem we saw? I don't want to take all 6. I don't want to take anything out, folks. What does the graph look like? It's not a parabola, it's cubic. Come on, folks. Get on track here. It's a snake. Is it right side up or upside down? We're looking for the largest. We're looking for the maximum. Does negative b over 2a work? No, because it's a cubic. So, we go back into y equals. I need a window. What is the largest x value that you can have? Look at the parabola. 2. 2 would be the largest x value you can have. So if I go into my window and I go -5 by 5, that will for sure be enough. As far as my y values are concerned, suppose x was 1. Then the area would be 24 minus 6, or 18. So if I had a y minimum of -50 and a y maximum of +50, I'll for sure see everything I want to, hopefully. If I don't, I'll just make it a little bit bigger. I go to graph, and there's a cubic where I can see a maximum. Now what? You'll be happy to know that of the 4 problems we do today, in your assignment, as you go through and choose problems, there are 4 that are basically identical to what we are doing. So Okay, it's time to answer the question. The question is find the dimensions. So what's the base? Excellent try, but not quite. 2.3, you got to double it. Now, I've got two ways to find the height. What do you think? I got two ways to find the height. I could either plug in something here to give me y, which is the height. What would you plug in for x? No. You'd plug in 1.15. Does somebody see another way that I can find? Yeah, I take the area, which is 18.48. That is the maximum area. And I simply just divide it by my base, 2.3. And that should give me the height, 8.03. You are asking an excellent question. Okay? And this is one of the most common mishaps with this type of a problem. Remember, we've written an equation not for y equals as in the height equals, but we've said y or the area is equal to. Okay? So, as you look at how this is set up, here's what we've said. Area in terms of x is equal to 2x times y. And what was y? Y was 12 minus 3x squared. So this is where the y is sitting. We have a new y. This new y represents area as opposed to height. Okay? All right, flip it over. Hockey team. We got two more problems. Cheer up, Charlie. Hockey team plays in an arena with seating capacity of 15,000. Ticket price is set at $14. Average attendance at recent games has been 9,500. If you want the attendance to go up, what should you do? Lower the ticket price. Market survey indicates that for each dollar ticket price is lowered, average attendance increases by 1,000. Find the price that maximizes revenue. How would I determine how much money I get? P as in ticket price times the attendance, right? I mean, if you want to know how much money you're bringing in, take the ticket price that you're establishing and multiply by the attendance, right? And so, great professor I had, actually horrible professor I had. Watch, because it's great advice. I don't know how to do it, so let's do it. The revenue is, what is the current price? 14 times, what's the current attendance? 9,500. Well, it's not going to stay at that, is it? So if we changed it, we would have 14. How much do you want to drop it by? What should we start by dropping by? $1. Sounds good. So let's drop it by 1. We're looking for a pattern here, folks. So I'm going to drop it by 1. I've got the 9,500 will be the attendance plus how many people will I get? 1,000. Now, instead of dropping it by 1, let's drop it by 2. Now we get 9,500 plus 2,000. Hey, I'm noticing a pattern, aren't you? So let's see if we can actually write an equation. R of x would be equal to 14 minus x times 9,500 plus 1,000x. It can't be more than 15,000. You're absolutely right. That does come up in your assignment as kind of an extension of what you're talking about. So you can check that out. That would then set up for what would the minimum ticket price be. You also see a maximum. Okay, so I'm going to multiply this out. R of x is equal to 14 times 9,500. 133,000. Let's multiply the inside and the outside. 14 times 1,000 is 14,000x. And then negative x times 9,500 would be negative 9,500x. That'll be 4,500x. Minus what? X squared. Sweet. What shape does it make? A parabola. Upside down. Are we trying to maximize or minimize? Maximize. At what point does that occur? The vertex. Do we have an equation for vertex? What's negative b? Divided by, what's 2a? Cross out the zeros. Negative 45 over negative 20. 2.25. What's the question ask? It doesn't ask how much I should drop the ticket prices by. It says find the price. How'd you get it, Michael? Yeah, he said 2.25 is X, which represents how much we're dropping it by. So 14 minus 2.25 will give us $11.75 will be the price of the ticket. Thank you so much. You have a great day. Last problem. I love this one. We saved the best for last. You can do it, kiddo. We believe in you. A rectangle is inscribed inside a semicircle. A semicircle. Radius is 16. What dimension should the rectangle be to maximize the area? Same type of problem. What is driving the problem? Maximize area. So I will write down area is equal to base times height. What's the base? Two X. No, Michael, I love it when you show stuff. I don't care if it's right or wrong. This is just good stuff. You're always trying to solve the problem. Can't be afraid to fail. Failure is an event, not a person, right? It's something that happens but does not define who we are. Don't be afraid to fail. Yes. Way to go. Okay. So, the height. So the area is equal to 2xy. Well, maybe if it's not there, we should come up with it. What's up, Braden? Okay, you had a thought and it ran out. Nemec. YouTube, my class is saying some wonderful things. Unfortunately, none of them are really correct, but it's great to hear it. So we've heard 1/2 pi r squared, which is a great thought. Braden, you think you got it back? I heard distance formula. I like that. Yeah. Okay, thank you. Well, whoa. Okay, so no. You said the area of a circle. Now, you said formula for a circle. What are you talking about? So you're referring back to this. Now, I want to be clear. your formula for a circle is the same thing as the distance formula, right? Which is the same thing as the Pythagorean theorem. So really, when people did this problem, they said the Pythagorean theorem or they said the formula for a circle. Let's be clear, folks. Formula for a circle being in the center at 0, 0 is going to be very simple. X squared plus y squared is equal to 16 squared, right? You remember that. If you don't remember that, then go ahead and make a triangle out of it. It's no big deal. What's this side? Y. What's this side? What's this side? And so you get x squared plus y squared is 16 squared. Same thing as the formula for a circle. Can we solve for y now? Y squared equals 256 minus x squared. Square root, so y is equal to the square root of 256 minus x squared. Ooh, kind of a cardinal sin there. Yeah, you can't take 25 minus 16 and say that that's equal to 5 minus 4. 25 minus 16 is 9. Square root of that is 3. So we can't take the square root of things that we're subtracting or adding like that. So we now have area in terms of x is equal to 2x times the root of 256 minus x squared. Do you know what that looks like? No. So we can't do negative b divided by 2a. So we better use our calculator. Look at your drawing. What is the largest value that x could be? 16. So if I move all the way out to 20, that should be enough, right? Suppose x was 10. Then I would have 20 times the square root of 156, which would be like 20 times about, say, 12. So looks like we're in the hundreds, maybe like 240. So if I go up to, say, negative 400 and positive 400, that should be enough to see everything. Uh-oh, what happened there? Oh, I didn't? Oh. There we go. Well, hold on. If you get you real excited about this, watch this. Yeah, it looks like the infinity symbol, doesn't it? Is that awesome? It's like the infinity function. Always taking it in. You like it, don't you? All right. When's your birthday? All right. I'm going to tell your parents what to get you. Okay. I'm going to get you like a piece of paper that has the infinity function written on it. And that'll be good enough, huh? Okay. More like a bow tie. We're not taking a dancing class. We're a math class. Okay, so let's get back to business. We graph it. What do I press? Second calculate, number 4. I want to find the maximum. Got a left bound. Got a right bound. And I end up with 11.31. So we've got this point right here, which is 11.31 and 256. So what does the problem ask for? Does it ask for dimensions or the actual area? Dimensions. So base is equal to 22.62 inches, and the height, I could take my 256, I just divide that by the 22.62. If you notice, I come back up with the 11, 31, or 32. You guys are excellent. Got to get into the problems. Now, I have told you that the problems that were on your assignment yesterday, okay, these 4 problems model almost identically 4 problems that you see in your assignment. You follow along, you should be able to get them. Now, I did add one more problem. You still just have to choose 5. But if you want to try 29, it's a classic problem. I don't want to kind of, entice anybody, but there's only been a few kids over the past number of years that have gotten this problem. It's a tough problem. But show me your star quality toughness and perseverance, and see if you get the Norman window problem. You just have to choose 5. Same thing as yesterday. You just choose 5 from that list. Same thing. Nothing new. I just added 29 as another option. I forgot to put that up. If you already did 5, then you're done. If you want to be an excellent, excellent mathematician, maybe you want to try all 10.
You are all, what was the word that he used? Excellent mathematicians. Don't let this defeat you. You got it.
Remember, climb the mountain of confusion.